Hello, and welcome to this conversation here at RISE, Computer Science and AI. My name is Martin Schörling. I'm a senior researcher at RISE. With me, I have Saif Haridi, professor at KTH, also senior leader at RISE. And we have the absolute honor today to have as a guest Ali Ghodsi, CEO of Databricks. Databricks is, of course, one of the most talked about companies in Silicon Valley right now, and it's welcome, Ali.
Thank you.
And Saif and I were just joking that we could have a competition on making a nice intro about you, but I think we want to hear from you yourself, your amazing journey that actually started here at KTH and SIX that then became RISE. So please take it away, Ali.
Yeah, I showed up, I think, in the early 2000s at SIX. It was a tail end of programming language research that we were doing. But I was kind of interested in another research area that also Saif and others in the group were also active in, which at the time was peer-to-peer computing. And the reason for that is that peer-to-peer computing, it was distributed systems, it was the internet, it was computers interconnected all over the world and so on. And we just were excited that maybe this is the future. Maybe in the future, we're going to see more and more of these distributed applications. So my PhD work started with Saif at the SIX group on distributed systems. And it was exciting years. And actually, it turned out we were kind of right that the next wave of software systems were going to be distributed. Those were formative years for me. So I was lucky to sort of, right time, right place, do research on the right topic that eventually would become, the main thing here in Silicon Valley was at the time, all these startups were starting in 2008, 7, 9, you had, Airbnb, Uber, Twitter, all these companies were starting. And what did they need? They needed people that understand distributed systems, who understand how you can build software that scales into data centers. So that's kind of how I got my start back at SIX.
Fantastic. Saif, do you want to shoot your first question?
Yeah. So Ali, you moved from Berkeley in a research group, and you started with other researchers, Databricks as a company. But under your leadership, the company has been transforming from, say, a managed cloud platform for Spark and its application to become a general data company. Can you explain this transformation?
Yeah, happy to do it. When we started in 2008 or 9 at Berkeley doing research, we were working with these Silicon Valley tech companies and the problems that they had. And we got to see what they could do with data and AI. And, I think we were at Facebook, and Facebook, said they can predict couples breaking up in advance using machine learning. And we thought, wow, that's amazing technology. We would like to democratize that and bring it to every company on the planet. We open sourced Spark, and we were hoping that would transform all these companies, but not much happened. So we started Databricks in the hope that we can maybe commercialize it and we can bring it to all these companies. So initially, the goal was just make Spark win, make Spark become the technology that everybody uses. So that was the goal the first 2-3 years.
Yes,
so
exactly.
Only one goal. And at that time, now people don't remember, but at that time, everybody was going crazy about this technology called Hadoop. So that was our main challenge, was that we kept telling them, hey, there's this other thing. We said, no, but are you doing Hadoop? And so that was the sort of biggest trend of the time. So our first 2-3 years was just, how do we get people to wake up and realize this Hadoop technology is no good, and they should get rid of it, and there's the next generation of things that are much better. In 2015, we succeeded with that. So Spark kind of suddenly took over, and it became the sort of successor and the superior technology. So then we started sort of focusing on how do we, and that's around the time we did the CEO transition, we started focusing on how can we build a sustainable business model around this. So we went to large enterprises and we started asking them, we gave you Spark, so you have everything you need. You're done, right? You can go do AI and you can succeed. And it turned out that Spark was not enough for them, they needed many other things. They needed help with very basic data problems. basic data problems that the big Facebook, Twitters of the world took for granted, or the PhDs at Berkeley thought are easy to solve, but they needed help with that. So we started actually building a technology called Delta, which simplifies and makes your data more reliable. So it goes back to the basics and just helps you with your data problems at its core. So we built that. Then we said, okay, now you have the data, you have Spark to do the processing, you have everything you need. But then it turned out they still needed help. They needed their machine learning folks that they had, the data scientists they had, still needed help to be more productive. They needed a way to track all these experiments, all the machine learning models they were creating. They needed to make them more trackable, more reproducible. So just basic operationalization of data science, they were struggling with that. So that's when we built MLflow, which was another open source project. So slowly we started listening to the customers and the organizations out there, and we built them what they needed to meet them so that they could make this sort of leap forward. So now we had built all these different technology stacks, but then people were saying, okay, we have all the pieces, but how do we put it all together? And that's when we started this journey of defining the data platform for them, which we call the Lakehouse, which is one place where you store all of your data in an open format. And then on top of it, you have integrated way to do data engineering, data science and machine learning, and data warehousing, all in one platform.
So maybe just is that you have now, really, you are encroaching on all these companies that are doing data warehousing, and you are taking the market from them, in a sense, by this what you call data lakehouse. So maybe you can talk about what is this data lakehouse now?
Yeah, it's very simple, right? Everybody wants to do machine learning and advanced AI, right? I mean, in a nutshell, it's a crystal ball of predicting the future. If you had a crystal ball, would that be valuable to an enterprise? Of course, everyone would like to have that, but it's not that easy. Start by crawling and then walking and then running. So crawling is, getting the data, cleaning the data, starting with the data, and maybe just asking basic questions from your data, which is, what happened in the past? What was my revenue last week? Which of my customers left? Which product sold well previous month? So that's like the beginning of starting your data journey. But then eventually you want to graduate and start to do more predictive technology so that you can tweak the questions and ask, which of the customers will leave me in the future? What's my revenue going to be next month? These kind of
business intelligence, isn't it? I mean, this is the business intelligence.
Yeah, but now we're asking predictive questions about the future.
Oh, I see.
And for that, you need machine learning. And unfortunately, today, to accomplish all of these things, asking questions about the past and asking questions about the future requires completely different technology stacks.
Exactly.
For asking questions about the past, you need data warehouses. You can ask, what was my revenue last week? But if you're going to ask, what's my revenue going to be next week, you need data science and machine learning technologies. Completely different software, completely incompatible. And actually, you need to hire different people. You need to hire, for the first one, you need to hire analysts. For the second one, you need to hire data scientists. And these people, they're different background, different teams, different technology stack, but it's the same data. It's data on your customers and your products. So what we want to do is simplify that so that you can bring all these technologies together into one architecture where you can store all your data and you can ask questions about the past, what was my revenue last week, and about the future, what's my revenue going to be next week. Sounds simple, but the problem is, historically, it was really hard to accomplish this because all the data warehouses were based on this interface called SQL, SQL. And it's great for asking questions about the past, but you can't ask questions about the future. So we have to modify that to a different sort of interface that you can then use to both ask questions about the past and the future. So that's what the data lakehouse is. And that interface is called data frames. And once you have that interface, it turns out you can actually easily build SQL on top of it to ask questions about the past, and you can build advanced machine learning to ask questions about the future. So it simplifies basically data management for all these enterprises.
So if I compare with other companies, they try to use SQL nearly for everything, as you know, I guess. Yeah. Whereas Databricks, and I see from some lectures on the data lakehouse, you have a lot of use of SQL, but you also have a lot of use of Spark. So what do you think are the benefits here between this combination, which is you don't find in other companies?
Yeah, it's the level of sophistication of the data user. There's a huge amount of people around the planet that know SQL and they can use SQL. They might not have computer science background. And it's great for them. And if you actually look at SQL in the surveys, SQL or SQL is, moving up. More and more people are using it. More and more people know about it. So there's no doubt that it's here to stay and it's amazing. So it's a great way of getting started if you want to ask questions about your data. But if you also look at the same surveys of what, how education is happening on the planet, Python is a big revolution that's happening. And it's actually even growing faster right now than SQL. So at all the universities, all these students that are coming in, they're learning Python. They're using Python for all kinds of programming. And you want to support both. And the Lakehouse essentially is the marriage of SQL and Python. So we see both. 97% of our customers are using SQL on Databricks. Over 80% of them are also using Python on Databricks. So it's not mutually exclusive. So you can start with SQL, but then, as you want to get more into production and you want to get into more sort of, predictive questions, you need Python. So you need both. And historically, these were incompatible and separate. They're now coming together.
But don't you need Spark also for streaming and real-time analytics? Huh?
That's a separate trend that's also happening. That's true. We're seeing more and more need for doing things faster and having more recency in your data. You can have a dashboard on the wall with numbers in it, which is great. But if the numbers are 1 week old, that's not great. So people want, can I get today's numbers? Can I get the number right now, what it is? So there is definitely, this last 12 months, we've seen massive growth in real-time use cases on Databricks. In fact, it surprised us when we looked at the data. We saw, I think, 160, 170% growth.
I see.
Maybe we could shift gears a little bit and talk about maybe your delivery model. As I understood it, you took an early decision to be a cloud company, but now, of course, lately there has been a lot of discussion around data privacy, and people maybe move on-prem, etc., etc. What's your take on the whole infrastructure and delivery model arena?
Great question. We took an early bet on the cloud. The whole business was built on the cloud. First 5-6 years, every pundit I knew, every expert I knew, and every go-to-market leader we would hire would tell us, you have to go to on-prem, you have to go on premises. That's where all the data is, that's where all the money is. But we kind of stuck to our guns and stayed in the cloud, and that served us well as everybody was moving into the cloud. Now, we're large enough that we could actually, if we decided, if we could go on premises, we could stay in the cloud, we could go hybrid. But I'm still more convinced than ever that the cloud is, we're going to stick to the cloud strategy. We're not going to go on-prem anytime soon. And the reason is simple. We can just make it much more secure in the cloud. We can make sure that we have people on call 24/7. We can do the monitoring. We can make sure that you get a great experience, even when it comes to privacy and security, compared to if I give you a CD, Martin, and you go install it somewhere on some data center that I don't have access to. And then if something is going wrong, if you're getting into trouble, if the data is being breached or you're having outages, you're calling me, I'm trying to figure out how to help you. It's better that the people that are building the software also manage the software. It also creates really good incentive alignment because we want the software to be secure. We want to have no outages. So we're incentivized to build it that way. So that's better than if I just give you CDs and you go run it off in some other environment. The other thing is, in the cloud, we can iterate faster. We can quickly see how people are using it. We can quickly upgrade the software. We can patch it quickly if there's a bug or if there's a security sort of, log4j, vulnerability. We can patch it very, very quickly. Again, on premises, I would have to give you a CD and say, please upgrade to this version, right? So we can just iterate quicker. And also same thing, if we build software that's not great, you will tell us, Martin or Saif, that, hey, I didn't like this latest version that was released yesterday. And we say, okay, we just upgraded you again. Let me know if it's working better now. Again, on premises, we would have to wait for salespeople to come, convince you to get the new version, wait for you to install and upgrade to it. It could take 6 months. And then you might tell me it wasn't any good. And then I have to go again, work on the next software cycle, which might take 6 months. So it just lets you move very fast and iterate quickly. And that just, you end up innovating faster and creating better software. I think those fundamentals don't go away. So I think the cloud is here to stay. It's superior. I think we're going to see more and more movement into the cloud. But privacy is real. And there are more and more privacy concerns and regulations happening, not just in Europe, but also in the US and other parts of the world. And that is important for us. So we focus a lot on that. We're obviously, it pertains to us as well.
Yeah. There are so many things happening in the cloud stack. I mean, the hardware is evolving, of course, and the whole AI evolution is very tied to that. GPUs coming and HPC and all kinds of stuff. So how do you see that? Is that a very important part of the capabilities?
Absolutely. That's another great point, that the cloud is important because we can stay close to the hardware. You know, we're on the latest machines, ready for them to come out, whether, you know, it's a Tesla 100 or a, you know, whatever the machine type is, we're exploring them, we're testing them, and then we're releasing those and managing them under the hood for you. So that's another reason that you can stay really close to it. On premises, this is difficult, right? I have to work with whatever hardware you happen to have in your data center. And you might have bought a bunch of really old machines that are, you know, you don't want to get rid of because, you know, you invested, you know, you want to write those off and you have them. So we can move faster in that way as well. And hardware trends are very, very important to us. I mean, this whole machine learning revolution happened a lot thanks to hardware trends, storage costs going down so people could store massive amounts of data. That data was then used to build better models, the training of the models using GPUs, as you mentioned. So super important to us, and we stay close to that.
But then, of course, I guess the big question is this Europe and US. You know, would you dare to comment on, you know, what do you see when it comes to European cloud infrastructure and the way forward there?
Yeah, I mean, so there are some initiatives in Europe. You know, we see mostly, you know, AWS, Azure is big in Europe, so that's what we see. We see Google doing better and better, and then in Asia we see Alibaba. Those are the four that we see, that we hear a lot of demands from. There are other clouds. We don't see the demand for those yet. There's also more and more regulation coming from Europe. I think that's good. I think it's good that people get to decide how their data is used and that they have a right to it and that they have a right to erasure. And so things like GDPR are good. And you can see that they're good because the US is basically putting similar laws in place with CCPA in California and other places. So it's actually good. It just means that we have to build the software in a way where we can track all the data and keep track of the data and give you the rights to see it and delete it. And data residency is another thing that's becoming bigger and bigger, which is, you know, where is the data stored? Where does it go? And what role does encryption play in protecting that data? Is it protected? Can you store the copy over in some other place, in some other country, if it's encrypted or not? What kind of encryption? So I think those are the things that the market is trying to figure out. But overall, I think it's good. I think we should work with the regulators and figure out what the best way forward is. You know, you want the citizens of all these nations that are using all the software to feel comfortable about the software, to feel like this is valuable to them. We're all for it. We work closely with them, and you know, we actually, the Delta technology that I mentioned earlier, we actually geared it and targeted GDPR for it, so that you could track information that you're storing. So you can say, hey, I'm Martin, I need to know what data do you have on me, and Delta actually makes that easier. And we also made it easier to delete all of that. So delete all the lineage of all the data related to Martin right now, because you know, he doesn't want that data stored anymore. And actually, so for us, actually, GDPR helped us boost the sales of that technology.
That's very interesting.
So overall, we think it's good.
Super interesting. Yeah.
Yeah. With any new technology, you know, technology has a tendency to move fast, way faster than the regulators can catch up and, you know, keep track of it. And I think it's good for technologists like us to work with them and make sure that we are evolving in tandem. Rather than just, you know, leaping away and then, you know, folks wake up and, you know, I think it's much better to do it early.
That's very interesting. All right, maybe it's safe back to you and some of our final questions.
Something. So Ali, you have been a co-founder in a company in Sweden and of course, a co-founder of Databricks. What's your reflection about starting a company in Sweden or Europe compared to the US? It seems a big difference between these two, especially when it's a core technology company.
Yeah, look, first of all, I haven't, that was a while ago when I did that. So a caveat with, I don't know exactly how it would be to start up in Sweden right now in the last, say, 5-10 years. But I would say just the access to capital here in the United States is a big difference. Probably with any place on the planet, but the amount of access to capital that you get, it's remarkable, right? So Databricks has raised, over $3 billion of funding, right? That's 30 miljarder, we would say in Sweden, right? That's a lot of capital to work with, and it helps, it helps move faster, it helps hire really good people, and so on. So I think that kind of investment would be good if we could get similar things back in Sweden.
In Europe,
and Europe in general, I would say. And I would also say that, a lot of Europe, or the places where I was, there's a lot of big companies, and there's a lot of support for big companies. But what about the small startups? In the US, where I live, there's so much funding and there's so much risk tolerance and risk loving that it's actually natural to start a company, fail, start another company, and say, hey, I'm a serial entrepreneur. I started 5 companies, they all failed. And it's, oh, that's great. Here's a 6th one. Here's some funding, right? So I think that then enables you to take more risks. And then a few of those will become Facebook or Twitter or Airbnb or whatever it is. And of course, for each of those, there's probably 100 that failed. But that way you can get, more tries.
All right. Thank you very much, Ali, for the time you spend with us, and we're really grateful to have you in this
Likewise.
interview.
Thank you so much.
Very much.
Thanks for having me.
Thank you, Ali.
Thanks.